Yeah, okay, thank you. Yeah, I'm Anne Kristin. I come from the Norwegian Center of Organic Agriculture in Tingvoll, quite far from here. And my role in the Urban Farm Project has been to lead a work package on soil and fertilization. And so trying to map the soil on the farms and ask about what they apply for fertilization. And some of the farms have their own animals, and it's not. Then it's quite evident what they fertilize with, and some also buy mineral fertilizers because there are some organic but also some conventional farms in the project. But even if no of the farmers in the project until now have been applying any type of urban waste-based fertilizers, there is a high interest among the urban farmers for trying to recycle more of the organic materials that could be available or are available in urban areas. And that, of course, that contains a lot of organic matter and many nutrients, and that's a very interesting approach that you should be self-sufficient in nutrients in a local area, but then also such materials come with some compounds or elements that you don't maybe like or at least need to control, and one example are the heavy metals or the potentially toxic elements, as I'm going to describe them in this presentation. So I think you already saw the very long title. We're going to talk about circular handling of nutrients and risk for accumulation of heavy metals in this urban farm soil. So what we did was to ask all the farmers to sample the soil on their farms, and some did it themselves and some asked for assistance, but by this Norwegian advisory service. Many farmers are member in this advisory service system, and they can take the soil samples. So what we did was to ask that was done on fixed sampling points, so that you can compare over time what is happening to your soil. And then it's very easy. You can use a cell phone and record the coordinates of that fixed sampling point and take some sampling sticks around, and then you can go to Kilden at NIBIO and get a very nice map of where your fixed sampling points are located. And then, so this is the table which shows the concentrations then of the heavy metals or potentially toxic elements, as we call them, on the 10 of our totally 11 farms where soil sampling was carried out. So you see 6 farms in Bergen and 5 in Oslo. I don't need to look at all these numbers, but the 8 we have been analyzing for 8 elements. That's arsenic, cadmium, chromium, copper, mercury in Norwegian kvikksølv, nickel, lead in Norwegian bly, and zinc. And there, if you look at the bottom lines first, you can see that there are some thresholds. There is one threshold in the national regulation about organic fertilizers, which is a threshold for soil quality. So if you want to use, for instance, compost from food waste on your soil, then the concentration of cadmium, for instance, in your soil should not be about 1 milligram per kilo dry soil. And then there is another regulation, which is about soil pollution, which is not very different from the regulation on quality. And then there is also, of course, the EU countries has regulations for this, but as you can see, they vary really a lot. They vary a lot, and that is also because geological conditions vary a lot between countries. So then you can really ask what is then really actually safe. But you can see that Norwegian regulations are generally quite low. And if you look at the results from the farms, then urban-based fertilizers, and that is compost from source-separated organic waste, mainly from household, but also could be from catering and retail, and we abbreviated that SSOW. And then you could also take that material and make a digestate from it in a biogas plant, anaerobic digestion. And then there is maybe a more familiar product, which is composted organic waste from gardens and recreational areas, often called green waste. And then we also included horse manure and poultry manure, because that is animal manure which is often commercialized, so you can buy it. and many small-scale organic farmers do that. And such animals could also maybe be, or are maybe also more often commonly found in an urban or peri-urban context. But we have not, of course, you could also include the sewage products, not least now because there's a lot of attention to straw white, which is a very useful product, and I would encourage that a lot, but we have not been doing that in this project, not to make things too complicated. And if we go straight then to, this is in a way to show how we did our calculations then. We have been taking the data, some data for Norwegian food waste compost, food waste digestate, and green waste compost, and then see, okay, if a farmer should just use that material and cover the nutrient needs of a carrot crop. You know, a carrot will need many nutrients, but here we just look at nitrogen, phosphorus, and potassium. You can see how much they need here in gram per square meter. In Norway, we have a very convenient system because we talk either about, we talk about areas in dekar, and that's a tenth of a hectare. And then the gram per square meter would be the same as kilo per dekar. So when we are, many farmers, for instance, would be used to think about how many kilo nitrogen I apply per dekar, and then it's the same amount in gram per square meter. So a carrot crop would need 9 kilo of nitrogen and 3 of phosphorus and 14 kilo of potassium per dekar. And if you want by hectare, you just multiply by 10. And here, if you look at what these columns show, they show how much of these different materials you have to apply if you want to cover the need for nitrogen, blue, phosphorus, orange, or potassium, which is then gray. And what you see is that if you use poultry manure, you don't need to apply very much. But you need to apply more to cover the potassium need than to cover the need for nitrogen. And if you go then to the example in the middle, the garden waste compost, you have to apply really a lot to cover especially the need for potassium. So what that really shows is that these fertilizer materials are not so well balanced, because you would, if you apply all you need to cover the potassium demand, you apply far too much nitrogen, much more nitrogen than the plant would take up. And then we could ask, oh, but is this really realistic? Because this would be 3 kilo of dry matter per square meter. Okay, if you say 50% dry matter in the compost, that's 6 kilo. And actually, that's not so far from what many, at least market gardeners, do. So an amount of 5 kilo compost, for instance, was something we were informed about, and I've been reading recommendations of how much compost to apply. And they can, that's not unrealistic. Some recommendations are even way above this. And one reason is that in this market gardening system, which is quite common in urban farming, vegetable production, I would say, then it's very much recommended not to dig this compost into the soil, because then you would have more weeds coming up, and that would take a lot of time, and that consumers would have to pay for a lot of weeding, or maybe do a lot of weeding. So that's really tricky. So you put the compost on the top, and then what happens to the nitrogen? It disappears, so you have to buy extra nitrogen to fertilize the plants. So this is something market gardeners really should look into, because Sebastian mentioned this planning tool we have been making. We have made an Excel tool for small-scale vegetable growing that you could use to see how much nutrients you really apply in different products, and maybe consider your nitrogen balance, because the numbers maybe don't look so nice. But of course, this is, like you said also in your talk, there's no support for it. It's not so much regulation when it's on a small scale, but still you really need to think about what you do. So here comes the it's also very, very many numbers. It's actually more to show you in a way how we did this. But we divided then into 2 regions with average concentrations in the soil in Oslo and Bergen region, and all these 8 elements. We skipped arsenic because it seems we're not going to have a national regulation for arsenic in the soil after all, so there's no arsenic here, but the other 7. And then we calculated if we use this very high amount of fertilizers, compost from food waste, compost from green waste, or digestate, how long time would it then take to reach this level of soil quality for each chemical element? And then you can see that if there is a yellow color, then the time is shortest. Then it's under less than 50 years before you will reach this soil quality limit or threshold. So you can then see that where the light yellow color is found, that is for copper and zinc. But these elements are also very important plant nutrients. So sometimes you need to fertilize, especially if your soil is a bit alkaline. Then, like in Denmark, it's a big problem that the plants don't get enough copper and zinc. So maybe it's not so dangerous that it's for these elements that we will first reach the threshold. And then if you look at the element like mercury, it's a really long time before you reach the limit because the concentrations are very low. And if you look at the poultry manure, you can see you can just go on because then it's very little heavy metals, but there is more heavy metals in the urban waste-based fertilizers. So this then, just to compare with the European Union, if you took the maximum level in the European Union, on the y-axis here are years. So you can see in Norway, it would take, for instance, for copper, less than 100 years with these 3 different waste-based products to reach the soil quality limits. From left here is compost from food waste, then comes compost from green waste, and then comes horse manure, just to show 3 different examples here. So first you reach limit for copper, takes much longer for nickel and lead, but then chromium, for instance, takes very long time. But if you go to the European Union, then we talk about thousands of years instead of hundreds of years. So then it's the question, is it really reasonable and is it really justified for Norway to have such strict limits? Because this would really restrict how much urban waste-based fertilizer you could apply in urban farming. So this is the slide with the conclusions. We need better fertilizers. They should be more balanced. Either you should do more to keep the potassium in the urban waste-based fertilizers. Because what we see is that the potassium concentrations are a bit below German data, for instance. Is this because we keep the windrows outside and we have more precipitation? Or is it something we could do to take care of more potassium? Could we get potassium from other sources, maybe from seaweed, or that's one thing. But then we also need to look into the regulations. So if I then read maybe here point by point, the values of potentially toxic elements in Norwegian urban waste-based fertilizers, they were all below the upper EU limit for organic fertilizers, but they were still classified as class 1 or 2 by Norwegian regulations. I haven't been saying so much about that, but there is classification for organic fertilizers in Norway, and they are quite strict. So, I mentioned already, these fertilizers are low in potassium. And then go to point 4, applications required for potassium supply of carrots. Then they imply that you would give much more nitrogen than recommended, and that such applications, they are not rare in small-scale growing, and the materials are often not incorporated. With the current soil quality limits, they will be reached relatively fast if you apply these high amounts of material. Such high application is then not permitted, but with Norwegian regulations, but just to see what it could mean anyway. And you would first reach the limit for zinc and copper, but these are essential nutrients for both plants, animals, and humans. So growers who want to use such fertilizers, they should monitor their soil regularly with fixed sampling points and include some analysis of potentially toxic elements. And the Norwegian authorities should assess soil quality limits and the limits for classification of soil amendments and rates of application, because the current levels don't support recycling of valuable nutrients and organic matter, which are available in the urban community. Okay, thank you.